When we are doing the composition of functions, basically what it means is we're going to be putting one function inside of the other. And we have to pay attention to we have to pay attention to two things. We have to pay attention to the inner function domain, the function that we put inside the other one. That's one of the things. And then we have to look at the range. So the range of the inner function becomes the domain of the outer function, because we're gonna be doing this with a graph. But if I have my f of x of, say, 2, and the output is 3, and my g of x, or g of 2, is 7, then if I'm asked to find f of g of 2, then what I'm really asked to find is f of 7. So notice how my g of 2 is what I put in, and I get an answer for that. I get the answer for g of 2, and that answer becomes the domain of what I put in for f. So what we're doing is we're putting one function inside of the other, and the output of my inner function becomes the domain of my outer function. And I say inner and outer because I always look at this as whatever's on the outside is the last thing we evaluate. Whatever is inside the parentheses is the first thing that we evaluate. So I have outer and inner. And for the most part, as you can see here, for the most part, when you compose both ways, they typically do not equal themselves. So what we're going to be doing is we're going to put one function inside of the other. And the notation is this. It is notated as f composed of g of x, or f of g of x. Now, when you see it in this form, I almost always switch to this form because it makes it easier for me to see who's going to be put into the other function, which function gets put into the other function. If you have a long list of compositions, which you can have, if you have f composed of g of h of x, then f is the most outside function, g goes next, the h is the most inside function. So compositions of functions doesn't just include two functions, it can include multiple functions. And you do it one step at a time. You're going to put the h function inside the g and that answer back into the f. So, what kind of questions do you have for me? So after I found the domain of each one of them, I'm going to put g inside the f function, and then make a single fraction. And the reason I have to do this is because I have to figure out what the domain of my final answer is. So I have the square root of 1 minus x squared over x squared, because they now have the same common denominator. And we got somewhat of a leg here. And then this is going to be equal to, let me see, just a second. So what I'm going to do is I'm going to unshare and reshare my screen, because whatever reason I've got a leg on my screen from what I'm writing and what's happening. It seems to be frozen, so hang on a second. So this step right here, what I'm doing is I'm making the same common denominator, because what I have to do is I have to determine the domain of my final answer. So right now, that's what I did there. So I made negative 1 as negative 1 over 1, so that I have the same common denominator, and I multiplied by x squared. And then what I did after that was I combined it up because I have the same common denominator. And then I'm going to use this rule that says if I have the square root of a over b, then I can take the square root of a separately than the square root of b. So I'm going to use that ability so that I can write this as the square root of 1 minus x squared over the square root of x squared. And so what this ends up becoming is the square root of 1 minus x squared over just x. Now, I have to talk about what the final domain is. This didn't pick up anything with the x cannot be 0. But this portion right here, I've got to ensure that that is the square root part is above the x-axis. Or in other words, I have to make sure it's positive. Now, I know that I can't put in 0, so I'm just going to focus in on this. I know I can't put in 0 here because I can't put in 0 in the denominator. But if I took 1 minus, and let's say I put in 0.5 squared, if I did 1 minus 0.5 squared, well, that's okay because I have 1 minus 0.25, which is 0.75. But if I did 1 minus, let's put in 2 squared, then what I'm going to get when I put in 2 squared is I'm going to get 1 minus 4, which is going to give me a negative 3. I can't have a negative 3 underneath the square root. I can't have a negative underneath the square root, so this is not okay. So what I have to determine is, in the square root part, where is this thing going to break between a positive number and a negative number? So what I'm going to do is I can do it by guess and check, or I can do it by factoring or solving. So 1 minus x squared, so again I'm taking whatever's underneath the square root part. And this time I'm going to ensure it's greater than 0, but I'm just going to set it equal to 0 because I know when it equals 0 that it is okay to be equal to 0. So I'm going to set this thing equal to 0 and solve, so I can do it by factoring. 1 minus x, 1 plus x, is equal to 0, and so I got x, 1 is equal to x, and negative 1 is equal to x. That's a place in which I am equal to 0. So if I put in 1 and negative 1 into this, then I know I'm going to take the square root of 0, which is okay. I can take the square root of 0. And 1 and negative 1 is going to also be okay in the denominator, so that's okay. What I know is that when I used 0.5, which is between negative 1 and 1, 0.5 seems to be okay. When I chose 2, which is on the right side of negative 1 or positive 1, that wasn't okay. So let's see if I chose something on the other side. Let's do 1 minus negative 2 squared, which gives me the square root of 1, and then negative 2 squared is positive 4. So this also gives me a negative, and that is not okay. So going back to all of this, I know that the domain restriction in the denominator is it can't be 0. And then in the numerator, I have to run between negative 1 and 1. Anything on above positive 1 is going to not be okay that I put in there. Anything below negative 1 is not going to be okay when I put it in there. So going back to all of this, my domain then, let me erase all the stuff I don't need, is my final answer domain with this composition of f composed of g, my domain, is this tells me I can't have 0. This tells me I have to go between negative 1 and 1. So I'm going to join these two domains together. I'm going to say, starting with negative 1 to 0, union between 0 to 1. And that is my final domain. What kind of questions do you have for me? Something that's so simple with a whole bunch of work behind it. So, what kind of questions do you have for me on this one? So, if there's no questions, we're going to go ahead and do the composition on this other way. So, when I compose this other way, I'm going to have this, I'm going to rewrite this as g, because that's my outer function, of f of x, which is equal to g. My f of x was the square root of x minus 1. So this is going to be equal to 1 over, and then I have the square root of x minus 1, the quantity squared, which is simply just going to give me 1 over the square root. When I square a square root, it's just whatever's underneath, so x minus 1. So that's my final answer. Now we're going to talk about the domain. The domain of my inner function, again, is inclusive. So the domain of my inner function here is inclusive of 1. But when I get finally done here, I don't actually get to have 1. So this one, I don't get to have 1 here. So my final domain answer is going to be domain of G of F is going to be non-inclusive of 1 to infinity. What kind of questions do you have for me? First part was, and I've got a answer of negative infinity to 1, 1 to infinity for the f function. Can I get confirmation for the domain of f, which is we have from negative infinity to 1, non-inclusive, union between 1 to infinity. Do we have confirmation on that? We've got some inclusive. We have some non-inclusive. So why is it non-inclusive? Why is it so it's so good? Why, Kale, can I not have the inclusive? You see the mistake, but why is it that you can't have it? So whenever I am doing compositions, if it's in this form right here, I typically will write it in this form here. That way I remind myself what is being put inside the other one. So, and I am dyslexic, so I have to make sure that it aligns to the way I look at it. You don't necessarily have to do that. I do because, like I said, I'm dyslexic. So for the first one, I'm putting in wherever I see x here, I am putting in x squared minus 3x minus 3. So this is going to be equal 1 over x squared minus 3x minus 3, and then minus that 1, because that 1 is still there, so minus that 1. And so this ends up becoming 1 over x squared minus 3x minus 4. Now I have to ask myself, can that thing ever equal 0? And I'll say, well, I don't know. Let's see if I can factor it. So this one does factor. It factors into x minus 4 and x plus 1. So this denominator does factor. So because it does factor, that tells me that x can't be 4 and negative 1. So the domain of this composition is the intersection of what I'm allowed to put in the first place, and I'm allowed to put anything in the first place. So I don't pick up any restrictions until the very final end. And so the domain for this composition, domain of f of g, is going to be from negative infinity to negative 1, union between negative 1 to 4, union between 4 to infinity. So I did pick up one extra restriction simply because of the way it was factored. How was that? Let's take a look at the second one. Now for the second one, I am putting in wherever I see x here in my g function. I'm going to replace both of those x's with 1 over x minus 1. So this is going to be equal to 1 over x minus 1, the quantity squared, minus 3, 1 over x minus 1, minus 3. So this is going to be equal to 1 over x minus 1, the quantity squared, minus 3 over x minus 1, and then minus 3. Now, if I wanted to, I can make this a single fraction. I'm not feeling it, so I'm probably not going to do it, unless I was required. If it said to simplify, then I would. Otherwise, I'd just leave it. And because it doesn't say simplified, I'm just going to leave it. Just like that, in all of its glory. What's the domain of this? Did I pick up anything new from my original inner function and then my final answer function? Did I pick up anything new? The domain for this composition, then, the domain of g of f, is going to be pretty much what I started out with, because I didn't Once I did the simplification, if I wouldn't have changed anything, and so the domain of this is going to be from negative infinity to 1, non-inclusive, and then 1 to infinity. I didn't pick up anything new with that composition. How was that? Do you have any questions for me? How are we doing? Okay. So if there's no other questions, we're going to go on and let's do f of g of 5 and f and g of f of negative 2. Now, I have one of two ways of doing this. If I have already done the composition, then I'm going to put that number into my composition. If I haven't already done the composition, then what I'm going to do is I'm going to just find the f and then the answer and put it in. So I'm not going to do these two. I'm going to do something different. I'm going to do this one right here. I'm going to say if I were to ask to find f of g of, say, 7, then I would have to find actually, let's do 3 because it's a smaller number. Let's do 3. F of g of 3. Then what I would do is I'd find g of 3. G of 3 is just going to be 3 squared minus 3 times 3 minus 3. So I'm going to just do 3 squared, which is 9, minus 3 times 3, which is 9. So that is 0. So my answer is negative 3. So what I'm really being asked to do is find f of negative 3. Notice how my output of my inner function becomes the input of my outer function. And so I'm now just going to put negative 3 into my f function, which is 1 over negative 3 minus 1. My final answer is 1 over negative 4. But I could have done it by putting it into here. So I could have done this exact same thing by putting it into that composition because I already did the composition. So if I have already done the composition, then what I'm asked to do then is, let me just erase this, is I'm really asked to put negative 3 in there. When I put negative 3 in there, or excuse me, positive 3 in there, I get 1 over. I have 3 squared minus 3 times 3 minus 4. So I have 1 over negative 4. So if I have already done the composition, then I can just go ahead and put that number within that composition. If I haven't done the composition, then I can do each one individually and then take that answer and put it into the outer function. So go ahead and do C and D, and just make sure that C and D, when you're doing that composition, that you can actually do the composition with the domains that are given to you. So I'm going to go ahead and put this on pause and do C and D, please. Okay, so we have agreement on the answer for C. We've got some agreement on the answer for D. So let's do C. So C, again, what I can do is I can put 5 in, or I can do it in the composition. Since we've already done the composition, let's just put that 5 in the composition. So it's 1 over 5 squared minus 3 multiplied by 5 minus 4. So this is 1 over 25 minus 15 minus 4. So 25 minus 15 is 10 minus 4, so 1, 6. So we all have agreement on that one. And then the other one, the second one, is the composing the other way. So again, we already have the composition, so let's go ahead and just put that in there. So I have 1 over negative 2 minus 1, the quantity squared, minus 3 over negative 1, negative 2 minus 1 minus 3, which is equal to 1 over negative 1, or negative 2 minus 1 is negative 3 squared, so that is 9, and then minus 3 over negative 3 minus 3. So I get 1/9 plus 1 minus 3. So I get 1/9 minus 2. Now, to make this the same answer, to make it a single mixed number, this would have been negative. So the way I do it is this way. I say 2 minus 1/9 is going to be 1 8/9. So, but it's going to be negative because the 2 was negative. So it's going to be 1 8. So negative 1 8/9. If you have it as a mixed number. If you have it as a improper fraction, then it would have been the negative 17/9. Which I believe I'd seen in one of the answers. So there is those two. How was that? How was that? Is there any questions at all for this? Okay. Now, if I am trying to find it in terms of the graph or in terms of the chart here, because there's some like this in the homework, you've got to figure out what you're trying to do. So I'm going to do this one right here. I'm going to call this A, B, C, D, E, F, G, and H. I'm going to do C. The way in which I'm going to do C is I'm first going to find F of 5. So I'm going to come across here to 5, and F of 5 is 0. So this is G of 0. So once I found the G of 0, then I'm going to come back up here, and I'm going to look for the 0, which is here, and the output when I put in 0 is 9. So my final answer is 9. Does anyone want me to go through another example of that? Okay, I'm going to do H, and then I want you all to do the rest of them. So if I'm doing G of 6, the first thing I'm going to do is go to where I've got 6 in my x-axis, so that, or my input, so that's 6. So my output is 7. So this is the same thing as G of 7. Once I do that, I go back to my x value of 7, and the output is 3. So my final answer on that is 3. So I'm going to put this on pause. And what I'd like you all to do is the other ones remaining. I did C and H. If you all could do the rest of them. You can put your answers in the chat box, or you can just unmute yourself. So I'm really being asked to find F of 4. So I go to the 4 and I get 1. So G of 8 produces 4. Oh, yeah, sorry, it helps if I'm paying attention. Is 1. Sorry, it's 4. G of F of 4 is 4. Yeah, I confused myself too. Doing G of 5, so I'm going to go to G of 5. G of 5 gives me 8, so this is F of 8. So then I go to 8, and it comes out at, helps if I'm, man, I'm really loving the circling of the G today. That gives me 9. Then I'm going to do G F of 3. So let me erase this and do F of 3. So F of 3, here's 3. So I'm really asked to do G of 8. So I go to 8, and 4 comes out. F of 4, so I'm going to go to 4. So 4 produces 4. So when I keep doing it, it's just going to repeat itself, so it gives me 4. It's not very interesting. Then F of 1. So F of 1 is 6. So what I'm really being asked to do is F of 6. So I go to 6, and then 2 comes out. And then my last one here is I have G of 2. So I go to 2, and 6 comes out. So this is G of 6. I go to 6, and 7 comes out. How was that? Okay. All right, so let's go ahead and do the same kind of thing, but now we're doing it with graphs. So with the graph, I'm not going to do these. I'm going to do G of F of, let me see, I want to do f of negative 4. So I go to, well, I'd go to negative 4 on my graph. I have to do something. Let's do negative, let's do 1, negative 1. Yeah, because that's on my graph. Let's do negative 1. So I go to negative 1 on my graph for f, and then I go up to the graph, which gives me that point, and then I go across to the y-axis, which is 1. So what I'm really being asked to do is g of 1. So I go to the g, input of 1, and then I go across, and my output is 1. So it's similar to what we had before, but now what we have is the graph. So we're reading it from the graph. And each time we read it from the graph, as I go to the x value, which in this case is 2 for a, so I'm going to go to f of 2, find the output for that, put that output into the g function. So go ahead and do a, b, and c, please. And then with c, you're going to have a multiple compositions. We have confirmations at g of f of 2, so I go first to the 2. So I go to 2, 4 comes out, so I'm really asked to be doing g of 4, which is 2. So I go over here to 4, and 2 comes out. Now I'm asked to do f of g of 4. So I do f of, I'm going to come over here, and I'm going to f of 4 is 2. I put 2 in, 4 comes out. So f of 2, which is giving me 4. And then f of negative 2. So this is equal to g, f of g of, I go to negative 2, 4 comes out. F of 4 gives me 2. So it's f of 2, which is 4. So we're doing a lot of chasing back and forth between the two. Lastly, in the last minute or so, is we're going to do decomposition. These are on the homework, so I want to talk about these decompositions before we're done today. So with the decomposition, I need to figure out what is the inner function and what is the outer function. So what I'm not allowed to do is I'm not allowed to say my g of x is just x. So we don't use g of x equals just x because that doesn't help me with the composition. So I have to figure out what would be the last thing that I would do in terms of the order of operations. And that's usually my outer function. The last thing I would do for the order of operations is take the cube root of the answer. So the cube root is typically, or whatever's the last thing you do with the order of operations, is typically going to be your outer function. So if your outer function is the cube root of x, that means your inner function must have been the x squared minus 8. So the trivial is this, and we're not going to use the trivial. We have to use non-trivial. So we want to think about what do we do in the order of operations. The last thing we would have done would have been the cube root of some number. So that would have been the outside function. The inside function would have been the first things that we would have done. So that's the easiest way to think about decomposition of functions. So take a look at this. Now, the last thing I would have done was I would have divided into, I would have taken x cubed it and divided into the x cubed. But that doesn't really help me on that one. The first thing I would have done is cubed those numbers. So now I'm going to think about what is the first thing I'm going to do, and that would give me my g of x. So the first thing I would have done is cubed my numbers. So that's going to be my inner function. My outer function is going to be, I would have taken that cubed function, subtracted 1, and then divided it into that cubed number. So my outer function is going to be the last things that I do. My inner function is the first things that I do. Using that information, the first thing I would have done is I would have taken my number x minus 1, and then I would have squared it, multiplied it by 2. I would have done the x minus 1 first, and then I would have subtracted 5. So the first thing I would have done on this would have done the x minus 1. So my g of x is x minus 1. My f of x would have been 2, squared that number I got, multiplied 5 by that number I got, and then added 7 to it. So when we're decomposing these functions, we want to think about either the last thing that I do, and that would be my outer function, or the first thing that I would do to that number, and that would have been my inner function. That is a decomposition of functions. If you have no questions, then you all have a great weekend. The only thing that is due is whatever we did this week. So I believe we did 1.3 and 1.4 this week. So the quizzes that are due on Monday will only be 1.3 and 1.4. All the rest will be pushed into the next week. The only homework that it will be due will be the 1.3 and the 1.4 homework, or 1.2. I think we finished 1.2 previous week. Whatever we finished this week will be due on Monday. You all have a great weekend. Stay safe. Stay inside. Try not to lick anything that you shouldn't be licking. Yes, you'll have quizzes over the weekend. Those are the ones that are just the ones that we covered. So if we finished, yeah, don't be licking doorknobs or anything, or shopping cart handles. Just don't do it. So the things that'll be due this weekend are the ones that are the ones that are that we finished this week. You all have a great weekend. Stay safe.